All right, they said the third time is the charm, so let's see if that's true. That's my third try on that video. All right, so the first thing we need to talk about, and the first thing I need to give you, are our double angle formulas. Now, I don't want to prove them because there is one of you who volunteered and who is pretty excited about doing that tomorrow. So I will not prove it in this video. We will have that proof presented to us tomorrow in class. But here are the formulas. So the double angle formulas, because there is more than one. So the first one will be for the sine. So we have sine of 2x, right? So if you have an angle x and you double it, 2x, that will be equal to 2 sine x cosine x. And again, it might look weird for now, but tomorrow we're going to go through that proof. The cosine of a double angle, so if I have 2x for a cosine, this will be equal to cosine square minus sine square. That's one version. But now, because I have squares, trig functions here, we know that we have a Pythagorean identity that has squares in it, right? Sine squared plus cosine squared equals 1. So if I wanted to, and if I replace this cosine squared with, so cosine squared x is the same thing as 1 minus sine squared x, right? That's just rewriting that Pythagorean identity. Replace this cosine square by 1 minus sine square. You would have 1 minus sine square minus sine square. So this will be the same thing as 1 minus 2 sine squared of x. So that's the second version of it. And now obviously we can do the same thing by replacing sine square this time, right? So sine squared will be equal to 1 minus cosine squared x. But we have to be careful when we do that because there is a negative here right in front of that sign. So we would have a negative here. So that would mean we would have a negative right there, and we would have to distribute that negative, make that a positive cosine squared. And then if we replace that here, that would give us equals. So we would have a cosine squared plus a cosine squared will be 2 cosine squared minus 1, right? Because this one here will become negative with that. So those are three different versions of cosine 2x, but they all come and emerge from the same identity. It's just using the Pythagorean identity sine squared plus cosine squared equals 1 to rewrite in terms of other things. All right, the tangent we're going to put on pause because we're going to look at that next video. And so now I just want to kind of put that in perspective, use it as an example, see how that will be helpful. So example 1. Let's assume we know that cosine of x is equal to negative 2 over 3. And we are told that x lies in, or the terminal side of x, I should say, is in, oops, I want my pen back, quadrant 2. And we would need to find cosine 2x and sine 2x. Okay. So we start with cosine. So let's go with the cosine first. Cosine 2x is equal to, now we could use any of those formulas, any of those versions here of the formula. And because I am given, right, we are given the cosine function. So I'm going to use the formula that only uses cosine in there because I don't know anything about the sine. So I'm going to use the cosine. So it will be 2 cosine squared x minus 1. And I know what the cosine is. It's negative 2 over 3. So that will be equal to 2 times negative 2 over 3 for my cosine. Square that because your cosine is squared, and then minus 1. And then that will just be a positive 4 over 9 times 2 will be 8 over 9 minus 1 will be equal to negative 1 over 9. Okay, so that's for the cosine of 2x. Now let's look at the sine. So for the sine of 2x, I'm looking at my formula for the sine of 2x, and I do need both sine and cosine, right? So here I'll have to do a little bit of prep work first. We are told that x is in quadrant 2, so I'm going to draw a triangle, place my x right there, and we're told that the cosine is negative 2 over 3, so cosine is adjacent over hypotenuse. And then for the sine, I would need to know what that other leg is, right? That y value here. So that would be the square root of 9 minus 4, right? Negative 2 squared, and that will be the square root of 5. So this side right there, this short leg is positive square root of 5. And now that I know that, I can go to my formula, 2 sine x cosine x. So that will be equal to 2 times sine x times cosine x. And now I know everything because I have my triangle. So the sine of x is opposite over hypotenuse. So square root of 5 over 3 times cosine x, and the cosine x is adjacent over hypotenuse, so negative 2 over 3. And that will be equal to negative 4 square root of 5 all over 9. All right, first example done. Let's go to another one. It will involve a little bit of, let's just do this one now. Example 2. Let's not make it too spicy. Is sine theta is equal to negative 7 over 25. And we're going to restrict that on the interval from pi to 3 pi over 2. And we want to find sine 2 theta and cosine 2 theta. All right, so what do I know actually? Well, I do know that I want to be on the interval from pi to 3 pi over 2. So this right there is telling me I want to be in quadrant 3. And so in quadrant 3, sine will be opposite over hypotenuse. So opposite will be negative 7, which makes sense. The y value will be negative there over the hypotenuse of 25. And then this leg of the triangle will be the square root of 25 squared minus a negative 7 squared. And when you simplify all of that, that will just give you negative 24. Negative because in quadrant 3, the x values are negative. Right? All right, so let's see if we have everything we need to set it up. So we want the sine. Let's do the sine first. We want the sine of 2 theta. And we know that the sine of 2 theta is equal to 2 sine theta cosine theta. So to the sine, we were given the sine, we already knew that, it's negative 7 over 25. But we were not given the cosine, and we needed that, but we do have it now, right? So it will be adjacent over hypotenuse, so negative 24 over 25. And when you multiply that all the way through, I did that in my calculator just a minute ago, 336 divided by 625. Okay. Now we still need the cosine of theta, so let me change color. Cosine of 2 theta is equal to, Now let's remember what the cosine of 2 theta says. Now I could use any of those formula I want, right? Really. And I'm just going to use 1 minus 2 sine squared. Earlier in example 1, we used 2 cosine squared x minus 1. Here I am given the sine function, so I'm going to go with the formula that uses the sine function. So 1 minus 2 sine squared is what I'm going to go with. And that will be 1 minus 2 times, I know the sine to be negative 7 over 25. And sine is squared, so I need to square that. And then when I simplify that, that gives me 527 over 625. All right. Now, sometimes we are not just wanting to evaluate something. Sometimes we want to manipulate to do other things with that. That would be maybe convenient to solve an equation or whatever it is that we're trying to do. So I'm going to show you how cosine 2 theta, and I'm using the version 1 minus 2 sine squared theta, can be reorganized and rewritten to finally give us a half angle formula. So here I have 2 theta equals 1 minus 2 sine squared theta. We already knew that, we had that up here, right? Okay, so how can I reorganize that? So I'm just going to say, well, this is negative and I don't want that negative, so I'm going to move it across, negative. So I'm adding 2 sine squared theta to both sides, and I'm subtracting the cosine 2 theta. So 1, this one stays, minus cosine 2 theta. Then I'm trying to get my sine squared by itself, so I'm going to do sine squared theta equals 1 minus cosine 2 theta all over 2, right? Because I divide by 2. And now, if I want just to, so that would be good for sine square, right? This is a good formula to know for sine square. But I can keep going and take a square root of that, so I would know that sine of theta is equal to what we had, because I took a square root here, I need to take a square root here. And because we take a square root, that will become plus or minus. So how do you decide where the sign will be, or if it will be positive or negative? That will be depending on where this angle right there, and I'm talking theta, not 2 theta, where that angle is located, in what quadrant. So quadrant 1 and 2 are positive, and then quadrant 3 and 4, we're going to keep the negative for those. So we just have to make sure that we pay attention to that sign issue at the end. Okay, we definitely can now keep going and say, well, okay, we just kind of moved things around, rearranged. What if this theta here, I want to rewrite it as being x over 2, for example. And let's see what happens then. So then I would have a sine of x over 2 equals plus or minus the square root of 1 minus cosine 2 theta, but if theta is x over 2, 2 times x over 2 will just be x over 2. And that is what we would use as a half angle. So if we had a half angle here, that's what we would use. And then you can do the same, obviously, I did it here with the sine, but you can do the same with the cosine. So you could do cosine of x over 2 equals, and I'm going to let you do that on your own, okay? Because I think it's good for you that you kind of process that and try to figure it out on your own as well. All right, Now let's use that, let's put that in action. So I'm going to say, I want to find the exact value, so I don't know what example that is. I think that was example 3. We want to find the exact values, or the exact value, I should say, of sine of 22.5 degree. Now, you're going to say, well, I'm just going to put that in my calculator. Well, what if you don't have a calculator? And let's try to see if we can tickle our brain cells and come up with a way of doing that using our knowledge of the unit circle. Okay, so you ready? Let's go. Obviously, 22.5 is somewhere in the unit circle, but I don't have a value for it, right? So I'm going to say, well, where is 22.5? It is in quadrant 1, right? Okay, so that's nice. Then let theta be equal to 45. Now, why would I want theta to be 45? Because 22.5 degrees, sorry, is equal to 45 degrees divided by 2. So I'm going to use that fact because I can compute sine, cosine values of a 45-degree angle. We know that it's in our unit circle, just not 22.5. Okay, so we're going to say sine of 22.5 is equal to, if this is theta, I'm going to say that's my theta divided by 2, right? We said we let theta be 45, right? So that will be theta divided by 2. So this is going to be equal to the sine of theta divided by 2. And just above here, we came up with a formula, right, of an half angle, right? Sine of x over 2 was equal to plus or minus 1 minus cosine of x over 2. So we're going to use that. So we're going to say this is going to be equal to, it's going to be a plus or a minus, but wait a second, 1 minus cosine of theta, and theta we said was 45 all over 2. And now we have to decide we want plus or we want minus, right? Because the formula has plus or minus. Well, remember we said we need to look at in which quadrant our angle lies. And my angle is in quadrant 1, right? This is why we wrote that here, quadrant 1. And therefore this is going to be plus, so I don't need to write it. Now, evaluate, right? Don't stop here. What is the cosine of 45 degrees? We know that. It's going to be a negative square root of 2 over 2. And then all of that is still going to be over 2. Now I'm going to do a common denominator here. So I'm going to say this is the same thing as 2 minus root 2 over 4. But then that square root of 4 in the denominator can be simplified. So that will be the same thing as 2 minus root 2 all over 2. And that's how we evaluate the sine of 22.5 degrees. That's what it will be equal to. All right, now let's look at another application. So this will be our example 4. And let's see how we would solve an equation using all of that. So we're going to say, let's have cosine of 2 theta plus 4 cosine theta is equal to negative 3. And we're going to solve on interval from 0 to 2 pi, which is just telling us that we're only going to do look at all the solution within one revolution, right, of an angle. We're not going to do past that. Okay, so when I'm looking, so you analyze here, right? So you say, okay, I have a cosine of a 2 theta and I have a cosine of theta here. So I want to keep the function cosine, but that 2 theta has to go. So when you're looking at your identities and your options, cosine 2 theta, where do I have them? Right there they are. The cosine of 2 theta could be rewritten, right, as 2 cosine squared x minus 1. So I'm going to go with that. I don't want to introduce a sine here either, right? So I want to just keep my cosine function. So let's go with that. So this will be the same thing. Cosine 2 theta will be the same thing as 2 cosine squared theta minus 1. That's what the identity tells us, the formula, right? And then keep your plus 4 cosine theta. And then I'm going to go ahead and do plus 3 and set that equal to 0 since I'm solving an equation, right? Okay, so the 2 cosine squared, the negative 1 and the 3 are going to together become plus 2. And then I have a coefficient of 2 everywhere, so I could factor out the 2. And then divide by 2. So I would end up with cosine squared theta plus 2 cosine theta plus 1 equals 0. And at this point, we're just going to be factoring that, right? So we just want to change that trinomial to a factor of 2 binomials. And so what can I multiply here and here to give me a cosine squared theta? Well, it would have to be a cosine theta and a cosine theta. And what can I multiply here and here to give me a 1? That will have to be 1 and 1. And then when you do the outer, you will get a cosine theta. And the inner, you would also get a cosine theta. And then you get 2 cosine theta, which is what we wanted here. So positive 1, positive 1. All right, and now this will be actually, by the way, the same thing as cosine plus 1. Some of you probably already caught that and remember that from Algebra 1 way back then, but this is how we normally would write that, right? But we want to solve the equation, so I'm going to move back a step. And I'm going to say, okay, we're going to have cosine theta plus 1 equals 0, or cosine theta plus 1 equals 0. Well, this is silly, right? You can see that both will give you the same solution, so I'm going to kind of ignore the one on the right and keep with the one on the left. So subtract a 1, I'm going to have cosine theta equals negative 1. And if you're thinking about your unit circle on where the cosine will be negative 1, that will be right there, right? Cosine will be negative 1 when the angle is pi. So the solution to that will be when theta equals pi. And then because we were told to just work on the interval from 0 to 2 pi, we know that this is our only possible solution for this one. All right, now I want to show you something about what we did the lesson prior to that with the sum of the angles. So I'm just going to sneak one extra example in here. We're going to have that example 5. And it's going to be sine of 11 pi over 12. And that's going to be equal to sine. So at this point, what I'm trying to do is I'm trying to see, let's make it in color here. I'm trying to see if I can change that. So I want a sine of an angle alpha plus beta to be equal to sine alpha cosine beta plus cosine alpha sine beta. So that's the sum formula, right? And so I want to see, can I use this formula to actually evaluate 11 pi over 12 because I don't know any angle over 12 in my unit circle just like that, right? So I need to break 11 pi over 12 into two different angles so I can apply that. So we know that 11 pi over 12 will be the same thing as 8 pi over 12 plus 3 pi over 12. Now, why did I pick 8 pi over 12 and 3 pi over 12? When you add 8 and 3, you get your 11 back. 12 is your common denominator. Now, why did I pick that? Because, first of all, it gives me 11 pi over 12. And if I simplify the first fraction, 8 over 12 gives me 2 pi over 3. And I know values on the unit circle for that. And 3 pi over 12 will give me pi over 4, and I do know some values in my unit circle for pi over 4 as well, so that's what I want to use. So, okay, so this will be equal to sine of, simplify that, so that will be 2 pi over 3. Oh, come on. What am I doing? Trying to hurry up here. And then 3 pi over 12 will just be pi over 4. So this is what we're going to work with. So sine of 2 pi over 3 is going to be equal, plus pi over 4 is going to be equal to sine of 2 pi over 3 times cosine of pi over 4 plus cosine of pi over 3, 2 pi over 3 times sine of pi over 4. Okay? And now I apply my knowledge of the unit circle. I know that 2 pi over 3 is going to be way up there, right? And so this will be negative 1/2 for the x, for the cosine, and then a root 3 over 2 for the sine. So sine of 2 pi over 3 will be a root 3 over 2 times the cosine of pi over 4, so that will be there, and we know that those are those root 2 over 2, root 2 over 2. So the sine will be a root 2 over 2 plus cosine of 2 pi over 3. So we're back to at this point here, and the cosine will be negative 1/2 times the sine of pi over 4 will just be a square root of 2 over 2. So I'm going to have a root 6 plus, oh, let's make that a negative. We have a negative there. Let's do it right away. So that will be minus root 2 all over 2 times 2 is 4. And that will be the solution to sine 11 pi over 12. All right, we're going to stop this video here. I think that's enough to get you started. Then what you need is just a lot of practice, okay? All right, I'll see you in class.